now I would like to invite Sri Rajashri Bhatt, the research scholar from Sustainable Engineering and Circular Economy Group at IIT Kharagpur, to give an overall view as well as present the project report of ITF LCA project.
Thank you, Dr. Chella, for this opportunity. I am just sharing my screen. So is it visible, the presentation?
Yes.
Okay, fine. So a warm welcome to all the delegates and our precious audience who are with us here today. I would like to take this opportunity to present our work on supporting the life cycle assessment activities to decarbonize the Indian transport sector. This work has been done under the supervision of Professor Brajesh Kumar Dubey along with the help of Dr. V.R. Shankar Chella. And now, before moving on to the brief background of this project, which Ms. Vatsalya and Professor Dubey has already elaborated in quite an extent, I will just go through it quickly. So the first slide here, you can see, like, I am trying to project the idea that why we have arranged this webinar or what has motivated us to come to this point. So as you can infer from this particular slide, that it hints towards a global climate change, which refers to the term global warming potential, or the global warming that we are seeing today due to the emission of various greenhouse gases. So there are various estimates which have already been made that suggest that by 2060, the global temperature rise will be by around 4 degrees Celsius. And this temperature rise, this will be accompanied by millions of deaths, as well as billions of dollars of loss also. And you can get an idea from this very infographic that these deaths will be caused by various air pollution, and the water bodies will expand because increasing sea levels, the water temperature will also become warmer. So it will become a better breeding ground for various diseases. And also, since climate change will also lead to various erratic behavior, the droughts will be more severe. So more people will suffer through hunger and famine. People will go below the poverty line. So these kind of things, they will be triggered with increasing global temperature rise and the subsequent climate change. And now in here, you can see that I'm trying to project the same thing, that the greenhouse gas emissions, they are continuously increasing for a very long time. And as per the data of 2019, it was around 50 billion tons of CO2 equivalent was emitted that year, out of which on the right-hand side, you can see in this pie chart that 15% of this was allocated to transportation sector alone. Now, this is quite a significant contribution towards the GHG footprint. So that is why it calls for the reduction of the same. Now, in here, among the various developing countries, you can see that this yellowish kind of line, it is for India. We are seeing that our GHG emissions are also increasing at a quite a linear rate, you can see from here, and it will continue to go so till 2040 and further if measures are not taken to curb these emissions. And these kind of emissions, they are quite expected with other economies also who are going through a transitioning through a GDP growth and moving towards the developed countries. So this is quite evident, but keeping in mind various sustainability goals set by UN as well as the national governments, we have to take certain steps, certain changes in the policy in order to reduce this. And now in this very figure, you can see that today India stands as the 4th largest emitter of GHGs with a contribution of 6.5%. Now talking particularly on Indian scenario, we are the 2nd most populated country, so we need to cater the energy demand of a huge population. So that has today made us the 3rd largest importer of crude oil as well. And out of this crude oil, the 70% of the diesel that is being produced, it goes into the transportation sector, while more than 99.6% of it goes to the transportation sector in the form of petrol. And all of these, including transportation sector and various other sectors, has made India to contribute to more than 4 billion tons of CO2 emissions each year, of which round about 10% is by the
Rajashri, your voice went away.
Transportation sector, of which a huge.
Yeah, you are back now. You are back now.
Okay, so where was the last point where I was? Was this point covered that India today contributes to more than 4 billion tons of carbon dioxide equivalent emissions each year? And of this, 10% is from the transportation sector itself, which is quite a significant amount and is close to the global average where we see about 14-15% emissions. And of this 10% emission, 87% is just from transportation sector itself. Now, some of the projected solutions that we often see today are the shifting towards biofuels, moving towards electric vehicles, hydrogen energy, refining the vehicle designing and modeling, then preferring to walk and cycle for shorter distances, optimized vehicle routing. So we have got several solutions in front of us. But it is very crucial for us to, before making a solution, we have to make sure that the overall or comprehensive impact on the environment, it should be a positive one rather than a negative one, or we are not solving the problem at all. One of the great examples in this aspect is that electric vehicles. Now, electric vehicles have very like no GHG emissions from the exhaust. So we often hear people saying that we should move towards electric vehicles. There should be more electric vehicles. But if we are really not focusing deep into this problem, we will shift this particular problem to another place in the way that if the electric vehicles are more, there will be a tremendous increase in the power consumption as well. And that power consumption will be supported with increasing energy production. And in a country like India, where about 60% or more of its energy is through coal-fired power plants. So this emission, which initially was coming from the vehicular exhaust, they will now come from the power plants. So we are just shifting the problem from one place to another place, and it is not exactly problem solving. So in order to get a comprehensive idea, as Ms. Vatsalya and Professor Dubey has already told us, that we usually use various environmental assessment tools, out of which life cycle assessment is one of them. And it has got 5 major components, as you can see on the left-hand side, that it begins with the goal and scope. We have to define that what is the goal of our project, like who is our targeted audience, what is the purpose of this particular study, and then based on it, we choose a functional unit and then a system boundary. Now, this selection of this functional unit and system boundary is very crucial, because whatever quantified impacts that we are going to obtain through a life cycle assessment, it will be representative or with respect to that particular functional unit. And on the other hand, this system boundary, as the name itself suggests, that system boundary is basically a boundary inside which we have got n number of processes, and those particular processes are only considered while calculating the environmental footprint. So this is where the goal and scope comes. And then when we come to inventory analysis, this is where we gather the data from various sources. And these data include various input and output of various material and energy streams, and sometimes potential environmental impacts of some raw materials that we are using, their background impact as well. And assumptions. While doing LC, assumption is one of the very important aspects, because sometimes we don't have all the data that we need. So we have to make some calculated judgments and then assume some data. So these also are accounted for in the inventory analysis. And after getting all this data, then finally we move on to the impact assessment part. In this impact assessment, as the name itself suggests, here we determine the quantitative impact of any process, of any activity, or any product. And these impacts can be categorized under various headings, like it can be through global warming, from ozone layer depletion, terrestrial acidity, human toxicity, like there are various categories for which we get quantified impacts. Now, after getting all these impacts, we have to interpret them, because this data itself, it means nothing. So we have to interpret the data, see which are the process hotspots from where most of the impact is coming from. And then after looking at that, determining different hotspots, we have to draw some conclusion and provide recommendations on how to tackle those hotspots, what changes there can be. For example, if I talk about Indian scenario, we are more of a coal-fired based energy source. Our electricity sector is based on that. So clearly that calls for that we should shift more towards renewable energy, and our government is already taking various steps in that direction. So this takes care of the conclusion and recommendation part. Now I will discuss briefly about the scope of our project, as my previous presenters have already put some light on it. We will be discussing about the biofuel and vehicular component, with major emphasis on the biofuel one. And in here, we will be looking at mainly bioethanol and biodiesel. And as you can see in here, that feedstock cultivation, then harvesting, delivery of that particular feedstock to biorefineries, and finally the biofuel production. These were the phases that were considered in this assessment. While in terms of vehicular component, for internal combustion engine vehicles, here we considered all the phases except the use phase, because the use phase will depend on the type of biofuel we are using or the type of fossil fuel, how much the blending it is. So that brings about quite some disparities into the data while comparing different studies. So we decided not to include that. And in direction of the electric vehicles, we were more focused on the manufacturing phase impact of the lithium-ion batteries. So doing all this, our aim was to structure all this data in such a way so that it can fit very easily into the GREET model, which you can see, like this is one of the example from where carbon intensity is calculated. Professor Dubey has also shared such the same photo with us. Here you can see that it considers or takes inputs from the cultivation phase right to the biofuel combustion phase. So our data will fit into this model at various locations, in various format, whatever is required. As a part of this study, we looked into various literatures, of which about 17 were from bioethanol and 19 were from biodiesel. Now, almost all of these were from Indian scenario. While on the right-hand side, you can see that this particular one is the vehicular component. In here, two studies are there, which we can find from open literature that caters to the Indian scenario. While we have also considered few studies from various places across the globe in order to get a more comprehensive idea as to what is happening at other parts of the world. And during this collection of data in biofuel production, we were more focused on the fertilizers and pesticides, herbicides that were being used, their quantity, the diesel and electricity consumption, because we found that the cultivation phase itself, it is a very heavy contributor to the environmental impact for various case studies. And when we come to the vehicular component, in here, the vehicle lifetime was a major point that was that we took the data. Then lifetime mileage, the weights of vehicles, the battery, as well as fragmented by like steel, aluminum, and plastic, different components of the vehicle. Their data was also collected wherever it was provided. Now, after gathering all this data, it was a bit difficult for us to compare them, different studies. The reason being that the nature of the LCA itself, whenever there is a change in the functional unit or system boundary, it becomes quite difficult to compare different studies. And on top of that, different studies use different kinds of allocation. And allocation is basically how we allocate the overall impact to different components to different products. So somewhere people use economic, somewhere mass and energy based allocations, and at times system expansion and substitution approach has also been taken. So in our study, we provided priority to the economic allocation. As you can see in here that the fossil energy intensity was 0.16 megajoule. This was an average value that we obtained by comparing studies which provided similar functional unit and system boundary, while overall energy intensity was 0.35 megajoule, the double the fossil energy intensity, while the well to tank emissions for the biofuel production was around 19.64 grams carbon dioxide equivalent. This was particularly for the molasses and sugarcane based, while for lignocellulosic feedstock like rice straw, wheat stock, for them, the fossil energy consumption was a bit higher side, while the overall GHG footprint, it became a bit lower than the molasses and sugarcane based sources. Now, this is a more of a summarized picture of what we found through our study. We found that when the left-hand side, this is about biodiesel, that when we are talking about biodiesel and using feedstocks like jatropha and such other karanja, which have to be cultivated because the seeds of their plant, they are the primary product. So a major part of the impact that is generated from the cultivation phase, it is allocated to that seed itself. So that is why here cultivation phase, it is having the highest impacts, followed by biodiesel production, and then the collection and transportation phase. When we shift to 3G feedstocks like yeast or microalgae, in those cases, the feedstock cultivation, they have been observed to have slightly lesser impacts than the other lignocellulosic feedstocks. Similarly, when I am talking about the bioethanol production, here you can see that the cultivation phase has taken a backseat. The reason for this is that in cultivation phase, whenever we are using feedstocks like rice straw or wheat stock, so they are not the primary product of cultivation. The primary products are obviously the rice and wheat grains. So whenever there is a cultivation and we have got a certain impact from there, obviously, if I'm talking in terms of economic point of view, so the most of it should go to the one that is priced more, which is the grains, the food, and the lower priced one, that is the straws, the agricultural residue, they should be allocated lower impacts. So that is why in here the cultivation phase has had lower impacts as compared to the one that we are seeing in biodiesel phase. And in both of these, the collection and transportation phase, they had the lowest impacts. Then we tried to rank the feedstock also based on different criteria, like what is the current trend, how much the ethanol or the feedstock itself costs government policy and various, these are all criteria we considered it, and these were ranked from top to bottom. These green one, these are the most prioritized one, and as we go down, the priority decreases. So there is a ranking that we perceived, and we thought that molasses is the most looked at feedstock right now, followed by sugarcane juice, and then damaged food grains and lignocellulosic biomasses. Similarly, a similar data is provided for the biodiesel production as well. Here you can see that we didn't find enough studies so that we can come around at a proper average value for the fossil energy intensity, but we did get a proper value for this overall energy intensity, which was around 0.51 megajoules per megajoule of the fuel produced. Then the well to tank emissions were 30.78 gram carbon dioxide equivalent emissions. And similarly, when we try to rank the feedstocks for biodiesel production, this is the similar kind of ranking. In the top, you can see that this is the most looked at source for biodiesel production. Although palm stearing oil, this is not produced in India, it is basically imported, but still it is the most looked at source. And this policy-based used cooking oil, this is the government is pushing for this source, but it is not basically feasible, because in terms of Indian context, very less of this used cooking oil, it is thrown outside. We try to use this oil again and again and again. So the perceived ranking that we developed is that palm based, then followed by jatropha, karanja, neem, and then mahua based feedstocks. So based on all this exercise, we also then further went to this vehicular component, where we found that vehicle production phase, it had the highest footprint, and then followed by the maintenance phase. Similarly, for lithium-ion batteries, the GHG footprint, it varied between 14 to 47 grams of carbon dioxide equivalent per kilometer distance traveled. And this range, it is a bit broad, because this data, it varies based on the type of battery that is being used. There are different kinds of batteries, so as the type of battery changes, so does the GHG footprint as well. And now, based on all this exercise, we came to some conclusions. Like, our project goal was to collect the data and structure it properly, then engage with various stakeholders. Like, that is where Professor Dubey also highlighted that we have to go and do some field visits to see and verify what actually is happening on field there, and add it to the current data, so that to solidify it and make it more concrete. Then spreading awareness through various courses and various modules. And this was our goal. Then our process hotspots, that is what we found through this data collection. And as you can see, in biodiesel production, cultivation emerged as a major hotspot, while in bioethanol, biorefinery was the one, and vehicular component manufacturing phase was having the highest footprint. So based on this, we came to some recommendations that we perceived, and that is for biodiesel production, since the lignocellulosic, if we particularly cultivate, we have to cultivate our feedstock, then there is a food versus feedstock debate. So in order to avoid that, it seems to be wiser to shift more towards third generation feedstock. And if I talk about the bioethanol refineries, the refinery process itself, that needs to be refined a bit more, so that its GHG footprints can be reduced further, while after that there is optimizing the vehicle modeling and its maintenance. And then structured data collection, because when we were gathering data from different sources, like due to the nature of the LCA itself, it was very difficult for us to compare various sources. So if there is a more structured way to collect the data and then provide a footprint, it will be easier for later to academians as well as policymakers to make more sense out of it. So these were some of the references that I had used, and then thank you for your attention.
Thank you, Rajesh, for a comprehensive overview on ITF LCA project.
Thank you. I'll just start sharing.